Ship maneuvering, as the most critical and high-risk timeframe in ship and port operations, requires thorough knowledge of its theory. But what if I told you that most of existing theory is wrong? The available literature is flooded with so-called traditional theory, which was initially established by Captain Rowe in his book, The Shiphandler's Guide. In summary, this theory introduces the ship's pivot point to explain the motion of the ship after the action of internal and external forces on the hull, tugs, rudder and so on. Because of its simplicity, it quickly took over the literature, educative videos and ship handling trainings. It is used at maritime universities and schools still today. However, there are authors which prove that, even though this theory can describe ship motion partially true, the explanation behind it is completely wrong. Let's break down the main points of traditional theory. Number 1. The position of pivot point depends on ratio between ship's speed and hull resistance. Number 2. Position of pivot point is forward when the ship moves ahead and aft when the ship is moving astern. Number 3. Pivot point is used to measure turning levers. Number 4. Efficiency of any internal and external force depends on pivot point position.
Amazing. Every word of what you just said was wrong.
Now, let's break down some actual pivot point theory. Pivot point is the point on the ship's centerline around which the ship temporarily rotates. It is the point where the lateral or drift speed of the vessel during turning and drifting is 0. Location of the pivot point in practice can be found by observing the lateral speeds of bow and stern. By connecting the bow and stern vectors, it is possible to get a line which represents the trend of lateral speed along the vessel centerline. The point where the trend intersects the ship's centerline is the ship's temporary pivot point. Now let's look at several more examples. When the ship is not yawing, the pivot point does not exist. Now imagine that the ship is stationary and pushed by tug located aft. Since the force is acting at the stern of the vessel, lateral speed vector aft will be greater than vector at the bow, thus the pivot point will be located forward. Opposite would happen if the tug is located forward. If two tugs are pushing the ship in such a way that it makes lateral speed vectors the same, then we can say that the ship is purely drifting and pivot point goes to infinity. But what if we have the same situation, only in this case the forward tug pushes with less force? In this case the drifting is more pronounced than yawing, thus the pivot point is located outside the ship's hull. Now the question is if this is valid when the ship is moving ahead or astern. Yes. Absolutely. The position of the pivot point can be anywhere on the ship's centerline, on the hull or outside of it, no matter the ship's movement. We can prove this in few practical ways. Imagine the ship is moving ahead and it is fitted with very powerful bow thruster. Now let's imagine that we start turning the ship by the bow thruster while the ship is going ahead. Even though the ship is moving ahead, the pivot point will shift aft. Now we have ship moving ahead with pivot point aft. This point alone proves that most of the ship handling books are wrong. Another example shows comparison of turning with only rudder and with rudder and bow thruster. Blue trajectory shows turning of the ship with only rudder air pivot point is located forward. Green trajectory shows turning of the ship with rudder and bow thruster. Action of bow thruster shifts the pivot point aft, thus removing the ship's drift and swept path. This kind of turning does not result in loss of speed during turn. Final example shows how the traditional theory can create wrong interpretation and accidents in real-life scenarios. Traditional theory suggests that the pivot point is aft when the ship is moving astern. Based on this, if we execute kick-ahead maneuver while moving astern, the ship would be able to execute this maneuver as seen on left-hand side picture. However, in reality, when the kick-ahead maneuver is executed, the pivot point will shift forward even though the ship is moving astern, and this turn is not possible as seen on right-hand side picture. What have we proved so far? 1. The position of pivot point depends on lateral speeds along the ship hull. 2. Position of pivot point can be anywhere on the ship's centerline no matter the ship's movement. 3. Pivot point cannot be used to measure the levers as it changes instantly with the change of the forces acting on the hull. 4. Pivot point is just a consequence of the forces acting. Forces do not depend upon pivot point position. In the end, the question is how come the traditional theory is still the most common theory used in ship handling. Professor Seong Gico in his work, Safer and More Efficient Ship Handling with the Pivot Point Concept, explains that ship handling professionals, particularly the seasoned practitioners, find it very difficult to accept these findings. This statement is mostly true. There are professors and maritime scientists who base their entire career on the traditional theory. For sure, it is not easy to accept that they were wrong all the time. Some authors accept traditional theory only as simplified approach. In the book, Ship Handling, author mentions traditional theory as the fast and simplified approach that allows fast assessment of ship's motion in real-life scenarios. However, if something is simplified, it should not be wrong. In some other books, which are written primarily by naval architects, it is not possible to find a pivot point as any influential factor. It is only a consequence of the forces acting along ship's hull whose turning arm levers are measured from ship's center of gravity LCG. So why there are many modern books which again copy the old traditional theory? Why authors do not make any true scientific research before publishing their books? Subscribe for more.